So now that we have introduced the end-to-end workflow and described the overall intent of the change, let's dive into the various merge requests that introduce the change. First, these MRs are part of the stack diff, meaning every MR is based on the previous one. And this means that the full implementation is available in the last MR if you want to test it. The first MR introduces the SbomScan model and the uploader. The model itself is relatively straightforward. It introduces a couple of columns that helps to keep track of the project, the CI job. It has the usual timestamps for created at and updated at for Rails. It has a text column for storing the status, which is related to the state machine and helps to track the progress of the SBOM scan. And then it has a couple attributes related to the file storage. As mentioned in the intro, we store two files per record, at least in the happy path, one for the SBOM document and one for the result file. The SBOM is uploaded from the client running a CI job, and for that one, we support direct upload. And we also support the enhancement that allows the file to be stored directly in its final location. This prevents storing the file once into a temporary location and then moving it to the final one. But because this happens in workhorse, it doesn't have any context about the record. And actually, the DB record doesn't exist at that moment. So we cannot leverage the final path that uses the SBOM record ID, for instance. So instead, we generate a random UID. We use that for the path on object storage. So we need to store a reference to that unique ID somewhere. And this is what this column is for. So we just have it for the SBOM file again. And the file store is telling whether or not it's stored on local storage or remote storage. We don't have any database indexes on that table. We don't need any, at least not now. We might want one on the created as column because this one is used by the cleanup process to determine if an SBOM scan is expired by looking at those created more than 2 days ago. But because the table is not meant to be huge, like we expect at most 300K records, for instance, it might not even be necessary. We will possibly revisit that after some testing. So the database model is inheriting the seg application record because this is the seg database is a new decomposed database along with the main and the CI. This has been done recently, and this means that this record will be stored in that specific seg database. We have a couple association and validation as usual, and then we have the declaration that instruct which SBOM scan uploader to use for which attributes on the model. We use a specific uploader there because we don't want to reuse the generic attachment uploader. There is an additional records called upload that is created when using the attachment uploader. And we don't want that. Apparently, that's something that we're starting to discourage. This type is growing at huge pace. It needs charging, and apparently it causes some trouble. So we now prefer to avoid using that. So this tells to use a specific SBOM scan uploader that has basically the same characteristics without that specific concern that creates the upload records. We also want to keep the automatic callbacks added by carrier wave, which save the file to the file system in an after save callback. We don't want to deal with file storage during DB transaction. So instead, those methods will be called manually in the service layer. Then we have an opportunity to set the default store for those SBOM file and result file attributes depending on the configuration of the instance. Then we have a state machine. Again, pretty straightforward. Created when the record is created, running when we start the SBOM scan, and finished or failed depending on the outcome of that scan. Looking at the uploader now, as I mentioned, we inherit the main GitLab uploader, but not the attachment uploader that has this upload concern. But we reuse most of the concern and extend the same modules as we do in the attachment uploader. We also have a bunch of overridden method there. It's just basically to provide a similar behavior whatever the upload method that we use. As I mentioned, when we use direct upload, for instance, we might store the file in its final location before the model exists. We cannot reuse the model ID. So we have another method that we can call on the class that generate a similar path but use a random UUID. Then we have factories and fixture file and spec files, but I won't look into those in detail. Feel free to have a look in the MR. So that's it for the first MR, and now let's have a look at the second one. So the second MR is introducing the service layer and the services for creating and processing the SBOM scans. The first service, the create scan service, has two public methods, the authorize and the execute ones. Authorize is a specific method called during direct upload by the API endpoints that helps setting the proper headers and configuration for workers to store the file directly. As I mentioned, we provide the final path here, for instance, in that configuration, and this is what workers will use to put the file in the right place in the remote storage. There is a check there on the file size also, for instance, to recheck the upload if it's too big. Then on the execute, we have a similar file size check. Then we create the record, store the file. Again, if it's just stored during with direct upload, the file is already stored. This is basically or nearly a no-op. There is still a couple operation happening there, but it's really internal to the upload. If you're not using direct upload, this is the moment where the file will be moved from cache or temporary location into its final location. If everything goes well and the record is persisted, we move on and we schedule the processing of that SBOM scan. And then we respond with the usual service response objects. Just a quick word on the object size, the maximum, artifact size. We rely on the existing limit we have for job artifact using the CycloneDX file type here. So this is really the same limit that we have today when the dependency scanning job is uploading a CycloneDX artifact at the end of its execution. For the SBOM scan, the process SBOM scan service, the process I will explain in the detailed worker just after, but basically the execution is as follow. We verify that the file the SBOM file is available, and then we start the scans by just updating the state machine. We parse the SBOM. This is existing logic that we reuse across the board in the Rails backend. In many of the dependency management or associated workflows, for instance, this is parsing SBOM is pretty known already as a logic here. We're not interesting anything. Same for performing the security scans. The security scan is performed using the security report builder that we already use today when we do the beta feature for SBOM-based scanning. And the result is formatted as a set of findings with the entity here in the save. Here it is. We just take the finding list from the security report that we've generated there and format that specifically so that we minimize the amount of formatting and processing we have to do in the client. And again, that is saved to a file that is uploaded to remote storage by calling these store methods or local storage. If local storage used, it will be moved to its final location from the temp file that we created there. There are a couple of things to talk about on the worker that is scheduled, particularly around the worker attributes for performance. I'm using the high urgency here. That's really desired because high urgency means the SLO for scheduling is 10 seconds. We really don't want to have the CI job to hang for too long or waiting for the scan to happen and the results to be retrieved there. So if we can use the high urgency, that's really, really good for us. There are some restrictions though to use high. This cannot be a CPU bound worker, for instance, and the execution has to be under 10 seconds for the 19.5 percentiles, if I recall correctly. We're pretty confident that in terms of performance, that will be the case. So we'll monitor that closely and verify that we can stick to the high urgency. We also have a concurrency limit here that is set to 25. This is based on estimated workload to absorb peaks of dependency scanning jobs based on the um, other workers that we have that are related to processing scans from CI jobs. Uh, that should be acceptable to process a peak without waiting too long or timing out on the CI job while it's pulling for the results. And this allows to not impact too much the high queue, for instance, the other high urgency items that could be in queues. There is also an option to not retry the job. By default, I think this number is 25. That's really doesn't make any sense that really doesn't make sense, yeah, for us here because again, the client won't wait for many retries to get the results. And in most cases, if something goes bad, it might not be retryable anyway. So we rather will just retry manually if there is a specific use case that justifies it. And um, if it's not successful even after a couple of retry, we will just fail it and stop retrying there. So we only retried twice, for instance. What else do we have here? The finding entity. So as I mentioned, we want to format things in a straightforward way for the client to process this. Um, that's just yeah, saving us some time on the client side. And then we have specs files and factories, but nothing super fancy to look at neither here. So let's move on. Have a look at the third one. So the third MR is introducing another service and a worker that handle the cleanup of the expired SBOM scans. This cleanup job is scheduled every day at 2 a.m. And it picks up a batch of expired SBOMs. So let's look at the worker. Right now, the batch size is set to 200s. So when it's scheduled, it will take the first 200 expired records and send them to the service. And once that's done, it schedules another batch 30 seconds later. So again, based on the estimated workload of around 100K records per day, this overall cleanup process should be taking around 4 hours on GitLab.com. The service is looping through the batch of records that we have selected there. And for each of those, it first tries to delete the files from storage. And only when that operation is successful, it will delete the records. So we collect the IDs of the SBOM scans for which the file have been successfully destroyed, and then we call a batch delete to for performance reason on all those scans. So this means if a file's deletion failed for any reason like a temporary network failure or whatever, we don't delete the corresponding record. We ensure that we only delete it when the file storage is emptied from those files. So the recording question will be reprocessed in a next batch, for instance. Um, yeah, nothing specific here. Yeah, the expiration age is set to 2 days right now. We might be even to go even lower if necessary. I think like during the first release and maybe for debugging purposes and see some trends that could be useful to keep it a bit more. But yeah, that's open for debate, and maybe yeah, we can reduce that to a day or even less than that, because usually a CI job should run for less than an hour, so it's unnecessary to keep it for more than that. I think we're good for that MR. The rest are again specs files. So let's move on again and look at the final MR, which is about adding the SbomScan API endpoints and direct upload support. So the API endpoint, sorry, the API endpoint is actually made of three. There are three endpoints that we provide here. The first one is about authorizing the upload. Again, this is what is called by workers during direct upload process. We require it to the some of the workers headers in the request to ensure this is coming from workers. We want to make sure that the job is authenticated. So those queries are only available from a running CI job, or at least you need to extract the job token from a running CI job, and that's what we use for authenticating. This API is not open to the public or any other type of authentication. It's really meant for being used inside the CI job, at least for now. That's its sole purpose. So we find the job based on the token and make sure that these are matching and the authentication is accepted. There is currently a feature flag check because that feature is beyond the dependency scanning Sbom Scan API feature flag. And then we authorize or not the upload by delegating that to the service as we've seen in the second MR. And then those are sent back as a result. We have then the upload endpoint, which is called when the worker's upload is finalized, or if it's not using direct upload, this is what is called directly by the client. Again, we authenticate, we check the feature flag, and then we call the servers to create the record and store that file. We reply with the usual headers and response. We use accepted here, as I mentioned in the overview. We don't because this is just a temporary response until the processing is completed. And then we have the download endpoint, which is again authenticating the job to make sure that you can only retrieve a SbomScan that belongs to the specific job that has been authenticated using its token. The feature flag check, and then we find the corresponding SBOM scan and check its status. Depending on the status, either return 202 or if it's finished, we present the file. And also, if the status is failed, we want to make sure we return a particular code that tells that there is no opportunity, there is no need to retry actually, because if it's failed, it's definitely failed. It won't be the resource will not be available later. So that's why we use 410 here. Um, is there anything else worth mentioning here? Feature flag, we mentioned it. The entity for presenting the record after we have created it is pretty straightforward. We just expose the ID and the download URL. Oh yeah, and then we have the modification on workhorse. As I mentioned, we need to declare the route that workhorse will intercept and call a specific handler for that. This is really for direct upload support. Then there is just some testing, and actually, I think that test is not correct. We'll have to change that probably. And yeah, this is just a linked file that needs to be adjusted when we modify some workhorse files. Anyway, I think that we are good, and that explain all the MRs. If you have any questions, feel free to reach out. And yeah, hopefully we will have this change stand into 18.2 behind the feature flag so that we can start dogfood that internally and then move on and yeah, roll it out to more customers.